In part 3, I ran a continuity test on the mirror switch's wire harness and found it to be good. The next thing on the troubleshooting list is the mirror motor assemblies, but before I can test those, I have to remove the door cards.
All you really need is a Phillips screwdriver or an 8mm socket, and it helps to have like a little hooked probe or something like this, because we got a couple of things we need to pop out.
The only trick to removing these little plastic caps is to avoid hooking the screw or its washer underneath it. You shouldn't get much resistance when trying to pop off one of these plastic caps. If you do, there's a good chance you're hooking the metal screw.
Next, we got 3 screws down here along the bottom. One here, and one up here. We got 2 screws up under this armrest. One more, which is hiding behind this plastic plate. So the clips are at the top and bottom of this back edge. Kind of have to just grab in the middle, pull like that. So you get the piece out. You see those 2 clips? I just grabbed right about in the middle there and pried both of those guys at once. And that leaves a single yellow cadmium screw. See, all right. All of our screws are out. There are pop-in fasteners back on this edge. I think there are 3 of them here, and there are 3 down in this carpeted section. I like to start down below, partly because you should be able to pull this out a little bit because the screws are out, and then get your tool up in there, slide it forward, start popping those guys out. There we go. That's 3. And then the ones in the back, same kind of deal. You can come up and liberate them. All right. Now, bring it down, because you see you got these lips up here that catch. So you got to kind of let it drop a little tiny bit. Get your wires out the way. There are cables in here for the door release. You can use a tool like this to get right behind the plastic part on the cable. Don't pry against the cable, of course. And just pop it away from the metal bracket. Give yourself some slack on the door card. And then you should be able to pop off the little end from where it was connected. So same deal here. I'm gonna pop the blue guy. So with the cables detached, now we can do wires. And the one that's grabbing the most is up high here. It's the memory switch. that black connector is what has to come off next. Press down that tab, jiggle the connector to release it. There's the release tab right there. This wire connector is for your courtesy light, and it just slides. There you go. And the door card is free. So with the door panel off, we can finally access the power mirror connector and release it. Press down on this tab and jiggle the connector to get it loose. In order to perform the mirror tests, I have to pull out some of the terminals. Some of these wires have to come out of the connector. And to do that, the first thing is to remove this lock. This little plastic lock mechanism prevents those terminals from backing out. And because we want the terminals to back out, we got to remove this thing. With that lockout, then we can start pulling out these terminals. We're going to free up terminals 1, 2, 3, 5, and 9. We'll start with this red wire. That's terminal number 1. I'm taking my flat blade, tiny screwdriver. I'm sliding that flat blade along the top of that terminal until it stops. And when it stops, that means I'm up against the little plastic clip that holds it in place. If I lever up on it just slightly, it should release that wire like that. Now I gotta get number 2. Excellent. For this mirror motor test, we need jumper cables to get from the battery to the mirror motor harness. And I have some wires that I normally use these for electrolysis. They've got small alligator clips on one end and larger ones on the other end. These should work just fine. So this first test requires putting the positive battery power to terminal 1 and the negative from the battery to terminal 2 and see if the mirror moves to the left. So on my car, red is number 1 and black is number 2. That makes it easy because we can do black, black, and red to red. And there goes the mirror. The second test here says reverse the polarity and check the mirror turns to the right. So I'm flipping black from the battery to terminal 1, which is the red wire. I'm taking positive from the battery and touching it to number 2, which is black. And the mirror is going to the right. Connect positive lead from the battery to terminal 3 and negative to terminal 2, and the mirror should go up. Negative goes to terminal 2, which is black, and then terminal 3 is white. It gets positive, and the mirror goes up. And then reverse polarity, check that the mirror goes down. So I'm moving the battery negative over to terminal 3, which is white, and touching battery positive to terminal 2, which is black. And down goes the mirror. Now this test gets a little more involved. It says to put together 3 1.5 volt batteries, dry cell batteries. I got my 3 batteries taped together with a positive wire and a negative wire. And I just want to verify with my voltmeter that we've got the juice we expect. All right, so we're getting 4.84 volts coming out of this. Positive goes to 5. And negative goes to 9. All right. Those are juiced up. Then connect the positive lead from the voltmeter to terminal 6 and negative to 9. Terminal 6 is still in my connector, and that's fine because I'm going to jam my probe down in here to touch that terminal, so I don't actually have to take it out. But then the negative lead has to go to 9. I'm going to put this alligator clip on here and grab 9. Okay. Apply battery voltage to terminals 2 and 3. Check that the voltage gradually changes according to the table below while the mirror moves between uppermost position and lowermost position. Positive goes to 2, negative goes to 3. Terminal 3 is white. And here we go. We're going to make contact on terminal 2 with battery power. Let's do that over again. You guys didn't get to see this. I'm going to touch this and see what happens. So our voltage is going up, up, up. It should go as high as 5 according to the instructions. And it just stopped at 2.99. It's in range, that's what we're looking for. It doesn't explicitly say to reverse the polarity here. It just says apply voltage to terminals 2 and 3. And I guess it means both ways, and check for these numbers. Black wire, I'm going to give it the negative now from the car's battery. And then wire number 3, which is white, gets positive. Oh, I've got to show you the voltmeter. Okay, so now the mirror is going up. Voltage is dropping. It's supposed to get under, yeah, down in that range. And the mirror maxed out. So that looks pretty good. But we got more tests. Yeah, for the left and right motion. Connect the positive lead from the voltmeter to terminal 4 and the negative to 9. Negative's already on 9. Lead number 4 is this light green wire for me. So I'm just going to jam my probe down inside the insulator there. Apply battery voltage to terminals 1 and 2. Inspect that the voltage gradually changes while the mirror moves left and right. Negative goes to wire 1, which is red. Wire 1 gets negative. Wire 2 is my black. And black wire is going to get battery voltage. Let's see if the mirror moves. I think it's supposed to go left. No, right. All right, it's maxed out. And then it just says to flip the polarity. So positive goes back to 1. Negative goes to 2, which is black. Positive goes to red. And let's see what happens. Mirror is moving to the left. Maxed out. I mean, we're close. This says leftmost should be between 2.8 and 5. We got up to 2.39. It says to check the right mirror too, so let's go over to the other side of the car and do that.
I ran all the same tests on the right-hand mirror. As you can see from these test results, most of my sensor readings are outside of their acceptable ranges. The instructions say that if our numbers are not in range, we got to replace the motor assembly. And that's easier said than done.
These motor assemblies are not easy to find in good working condition, so I'm going to try another approach. Since my sensor readings are way out of range, I suspect that the magnets that are read by the sensors are corroded. One possible solution we can try is to pull those magnets out and clean them. Now the way to do that is to pull this mirror glass out. It's attached to this white plastic backing, and it has clips down here that snap in like that. So what I'm going to try to do is use a trim removal tool and hook the black plastic, pull hard, and release it from this white plastic piece. It is safe to push this mirror in at the top to expose the bottom edge. Just be gentle with it. I know that sounds bad, but that's actually okay. I'm just going to try to protect the paint. Okay. Yeah. And then you should be able to gently lift the mirror out. And then there are two wires in here. That's for the mirror heater. This pair of wires is routed through a couple of plastic keepers. Just gently slide the wire out from underneath. Wrong way. Like that. And this little connector just pops off. Just gently work it out like that. The next thing is to remove this little keeper that's in here, and it requires a needle nose pliers. Just grab either side of that little T-shaped piece of metal, push it in a little bit, and give it a quarter turn counterclockwise, maybe a half turn, maybe a whole turn, and out it comes. It's a little spring-loaded keeper. You can see this piece becomes loose, except that it has those two threaded rods. We got to pull those out, disengage them from the motor assembly. I know it sounds nasty, but you're not going to hurt anything. And there they are. You can see they got a little bit of road dirt on them, but on the ends here are magnets. If you get corrosion built up on these little magnets that are inside those plastic shafts, then the sensors are going to get faulty readings, and your mirrors probably don't work right. Let's go get the other one. They do look a little crusty, like there might be some rust on there. Let's go clean these up. All right, now that these threads are nice and clean and the sockets are free of debris, they seem to be moving smoothly, the next step is to focus on these magnets. And what I'm going to do is just get as much rust and debris, anything that's in there, just clear that out as best I can. There are these little slits
along the sides of the magnet. And they're there because of these, I guess you'd call them release clips, but I find that taking something really skinny and sliding it up through those slots allows you to scrape quite a bit of crap off the magnets. X-Acto knife is pretty good for getting in there if you don't mind dulling your blade. This one's already pretty dull, so I'm not worried about it. The next step. So I got a bowl of warm water here and some CLR. And this stuff's good for soaking things that are corroded. I'm gonna just do about a 50-50 mix. And then I'm just gonna let these guys soak. I'll put this dark side in there for sure. Okay. I'm gonna let those sit overnight. I applied a thin layer of petroleum jelly to the threaded shafts and their ball joints to help reduce drag on the mirror motors. Then I simply reversed the removal process to reinstall the plastic backing plates. I reran all 4 of the mirror position sensor tests on both the left and right mirrors. The results were slightly better after cleaning the magnets, but I later realized 2 things that probably caused some improper readings. First, I found that one of the magnets in the right mirror had become partially dislodged, which means it wasn't positioned correctly relative to the horizontal sensor. That's probably why these 2 numbers are out of range. Second, I found that 4.8 volts might have been too low for the sensor input. It turns out the sensor readings are directly related to how much juice you feed them. Had I run the test with, say, a full 5 volts instead of the 4.8 volts from the 3 dry cell batteries, these low sensor readings might well have jumped up into the acceptable range. Either way, I still don't know if these motor assemblies are good. Let's take them apart and see what we find. To remove each mirror, I first took out all 5 Phillips head screws along the bottom edge of the window surround. I then used a trim tool to release the 9 clips holding the other 3 sides of the bezel in place. Each mirror is fastened with 3 Phillips screws. This connector will fit through the hole. Removing the mirrors from the car wasn't absolutely necessary, but it did make the tests easier to run. So here's the motor assembly that I need to rebuild. It's got 4 screws holding it in, one on each corner. So
there's a motor assembly. There's one yellow cadmium screw on the back that holds the case together. And this little cover just lifts off. Looks nice and clean inside. In order to take this gearbox apart, I got to get this printed circuit board out of the way because there's a screw just below this printed circuit board that's holding everything together. To move it, we have to melt the solder on these two motor wires for the vertical motor and pull the wires out, and that way we'll be able to flip this printed circuit board out of the way and get that screw out. I'm going to use this, clamp it to my table, and then I'll put these alligator clips into the screw holes. That way it won't go anywhere. So I'm just going to use the soldering iron to heat up that solder, and I'll use the needle nose to pull the wire down. There's one wire. The insulation pulled off. The black. There we go. All right, so with these wires freed up from the motor, this printed circuit board can be freed up too, and it requires popping it up off of these white plastic positioning pins, like so. There's the screw. And this screw is just like the other one we took off from the back of the case. And then this comes apart like that. Those are your two motors and their drive gears. This looks very clean inside, but that grease that's in there is 30 years old. So I think what I'll do is take this all apart, clean those gears up, and re-lubricate them. Now these gray gears are just reduction gears, and they're identical. You can swap them and they'll still work. And the same is true for these drive gears. These are the ones that actually engage threaded shafts. Threaded shafts slip inside these gears, and that's where you get that noise that we were hearing earlier that sounded so nasty, like that. And that noise is coming from this little metal clip. It kind of looks like a cotter pin. The two legs of the cotter pin are not aligned. And the pitch angle on those two legs is the pitch on these threads. So you can see that cotter pin can spin around and around on that threaded shaft. Move its way up or down. Since one end of the cotter pin is open, the legs of the cotter pin are able to spread apart and allow for the threaded shaft to slip, kind of like that. Ah, there is some dirt in there, mixed in with the 30-year-old grease. This seal also comes out. And it's worth cleaning this too. I should point out too, on the side of the case there are these rubber seals. They seal around the threaded shaft. Try to keep the dirt out. So we'll give those a good cleaning too. Here's some warm water, a little bit of dish soap.
And this is just straight water. For some reason, this circle looks different from that circle. Oh yeah, there's a little tiny washer on there. That's different. I have not seen this before. I haven't seen this in any of the other ones I've worked on. Huh. Put this little spacer back in there. I just want to put a thin layer of grease on these teeth. And then the little cotter pin, you got to slip it in from the side that has the bigger opening on it. And then the two little legs should pop out the two holes on the opposite side, like that. And then these should be liberally lubricated with Vaseline. We can set this guy in place. Cotter pin slips in through the big hole, and the two little legs pop out on the other side, just like that. Same with these reducers. I'll just put a thin layer of petroleum jelly on all the teeth. Okay. I just generally put it right back the way it was. You can put these covers on now if you want, or wait. There is some of that petroleum jelly in here as well. I'm going to give it a quick cleaning. So let me take you out again. Let's clean up some of that old grease. I got to replace the lubricant that I took out. Before I put this back together, I think I'll show you how these sensors work. So here's one of these threaded shafts from a different mirror. So you got to imagine that this cover's in place, and so the shaft would run through that gear and then extends through this hole. So this shaft is going to move forward and back depending on where the drive gear, is positioned. And as it moves back and forth, that magnet's position relative to the sensor right there, that magnet's position changes. And the sensor gives a different reading depending on where that magnet is. And that's how it tells the ECU what the position is. I'll give you a closer look at that sensor. There are two of them, of course, one for vertical, one for horizontal. And that little integrated circuit right there, that tiny little black rectangle with the 4 terminals on it, that's a sensor. As I said, it reads that magnet as the magnet moves back and forth through that hole. And there's, of course, another one over here. That's the basic mechanism. That's how it measures the position. Means you can put this back in. I don't want either one of these to be upside down, really, so I tend to tip them up together. Got a little screw. Before I go any further, I'm just going to do another test. I want to make sure our gears are aligning and things are moving as expected before I put it all back together. Again, I don't really care which is positive and which is negative on this. Probably can't see it very well. Let me pop this off. You can see it's turning that gear. So that's the expected behavior. And we can test the other motor using these wires. See it turning around in there. So the gears seem to be lined up well. Then, you'll notice we got some alignment holes here. There's a medium-sized hole here that lines up with this. So that's the boss for the screw that holds the case together. And then there are 2 smaller holes, one here, that mate with these 2 alignment pins, white plastic pins right here and here. So all you got to do is get those lined up. And be careful of these little sensors that stick out. I want to make sure that they stay well aligned. And that just snaps on. These have to be resoldered. Oh, there we go. Let's test it. To that motor. Okay. Got to line up these wires. This case has little wire openings. Those have to get lined up. Right. It ought to be like that, where there shouldn't be any gap. If there's a gap, maybe you got one of them wires pinched. Just make sure that they're sitting in those grooves, like so. Then we get this other little screw. And that means this can go back in.
that opening lined up there to receive this. That means we're ready to run this mirror position sensor test again.
I reran all 4 of the mirror position sensor tests on both the left and right mirrors, while still feeding in the same 4.8 volts. This time, all the sensor readings were in range. As an experiment, I bumped up the sensor input to 5 volts, then reran the tests. The sensor outputs generally went up, most importantly the ones that are expected to be in the range of 2.8 to 5 volts. But consider this, changing the sensor input from 4.8 to 5 volts, an increase of only 4%, boosted the sensor output by 6%, meaning a change in the sensor input voltage was magnified in the sensor output by 50%. Why does this matter? Because according to the service manual, a mirror motor assembly passes or fails this test based on its sensor output, which is a direct function of its input. That input comes from 3 1.5 volt dry cell batteries strapped together, which in my case happen to produce 4.8 volts. What if I had grabbed 3 different batteries that produced only 4.5 volts? I might not have been able to get my mirrors to pass this test. Anyway, I'm calling these mirror motor assemblies good. Time to put the mirrors back on the doors.
There's only one small trick to putting these wires back into the connector. The terminal has to be aligned properly when it goes into this white plastic connector. What I do is I put this release clip at the top, make sure that's pointing up, and then when I stick this terminal back in, I want to make sure that little tang is down and that of the 4 sides on the end of this terminal, the thicker side is down. So this orientation. Also make sure that that little rubber gray insulator is lined up correctly to fit into the hole. Mosquito. If it's incorrectly, it won't pull back out. So that's wire number 9. Wire number 5 is a pink one. Making sure I got that tang pointing down. Just clicks right in. The white wire is number 3. Black wire is number 2. And red wire is number 1. Then, before we can plug it back in, we have to reinsert the little plastic lock, this thing. And with the release clip up, those little dog ears stick down as you slip it back in. And it doesn't click or anything, it just slips in. Kind of bottoms out, and that's it. Once you've done that, you click it back into the connector. I like to tuck these wires back there. Okay. Now we can put that window bezel back on. Just snap these top ones in. Ones along the back are a little trickier. There we go. Oh, that little guy didn't line up. There we go. Gotta get this little cone-shaped thing to fit into that hole right there. Like that. All right, now we can put the screws in and use either a Phillips screwdriver or an 8mm socket. Let's do these middle-ish ones first. I won't tighten them all the way first time around. I'll just make sure they're threaded. Okay, then there's a little piece we got to stick in up front here. This little plastic piece. That's what's up here. Feed this wire harness through. Now we got to hook up these cables. Usually do this bottom one first. It's the blue guy. Bring this thing over here. Snap it in place. Slip the cable end down into that opening. Pull this white guy back. Line it up with the bracket. Click it in. Then we need the black connector for the memory switches. We got to get the door card kind of close. Not a lot of slack there. Then we have this flange up here that has to tuck up under the window bezel. On this bottom corner of the window surround, there's a locator pin that goes down into this door panel. Get that lined up. Focus on getting that guy up nice and snug. And then the 3 clips behind this carpeted area should line up pretty well. Let's start with this little yellow cadmium screw. Lift up a little bit on your door card so you can thread this screw better. Don't put it in all the way yet. Let's get it nicely threaded. Then we'll do these armrest screws. Got to go up at an angle. Don't put them in all the way yet. Okay, got that threaded. Let's do these 2 kind of chonky screws that go on the front edge. Again, I'm not putting them in all the way. Not yet. And they got the 3 little screws for the bottom edge of the door. So, door card feels pretty solid. Cinch that guy down. Okay. Feels like all of our fasteners are seated. So now I'm going to finish cinching down these screws. Put it on the cap. And then we can put our switch back on. White connector, for the windows. Blue connector for the mirrors. To reinstall it, keep in mind there's a flange back here on the trailing edge that has to tuck under this door panel. So when you put it down into the opening, keep it forward a little bit until you drop down and then slide it back. And then you can just press that front corner down.
Getting back to the troubleshooting steps, the next thing on the list is to test the power mirror ECU. We'll tackle that in the next video. Keep watching to find out what happens.